our circuit will be like this. As this is P, this is N, this is base 2, and this is base 1, and this will be connected to emitter. As then one thing, important thing is, if this is resistor, as for example I have supplied 5 volt, then here it will be 5 volt, here it will be 0 volt. Yes, 5 volt, 0 volt, 4.9 volt, 4.8 volt, 3.2 volt, like this drop. Yes, the same concept will be here like this. First of all, how BJT works is, this is P and here I connect BBB. Here is no voltages, here is no voltage applied, 0. Yes, nothing. In this case, this is B2, this is B1. In this case, our here more voltage appear and here it will appear less voltage. And this is, as this is P, here some kind of junction will be formed. As here some we have here, let's suppose it has 0 volt and it has some volt, like for example if this is 5 volt, it must be like that, around 3 volt. Okay, then this is N and this is P, reverse bias. Okay, reverse biased. Now the second case, if we apply here the voltage, let me draw the circuit. This is BBB, it is constant for now, constant BBB, and this is P, this is N, this is B2, this is B1, and I applied voltage limiting the current. Okay, this is BS, this is emitter, this is emitter, this is B2, this is B1. If I increase, BS is increased, then this point is, let's suppose I want to suppose this one is B1, then it will be forward bias, biases. Then the current flows is this, in this way, in this direction. And if the current flows, more and more current will flow. Yes, more and more current flow, then B1 will be decreased, because resistance is decreased. And in this way, as long as this BS is greater than B1, then current increased and UJT is in on state. And the diagram here for this is, during no voltage there is little current and it will reach to BP point, and after increasing current, yes, let's suppose this is current IA, after IA is increased, this voltage got reduced. Yes, current increase, resistance decrease, and voltage got decreased. The point here got decreased to some value point. Yes, and which is called, as the current is increased from here point to this point. Yes, from this point to this point, as the resistance is decreased, voltage is also decreased, current increase. This is called negative resistance characteristics. Now this is cut off region. Yes, this is saturation region. This is saturation region. This and this is the on state. And how can we use this UJT as relaxation oscillator? Okay, suppose we have source here and this is on off, then here we have resistance, we have here this is variable resistance, this is Vi, this is capacitor C1, and I have here UJTs, UJT, this is R2, R1, and here dim ball base. This is now let's suppose our interest is to see what is happening here. Suppose this is switch is closed, then after it is closed, then the capacitor gets charged. Capacitor gets charged here until this BE is less than the voltage required to trigger, yes, required to trigger UJT on, that is the capacitor will be charged. As long as after this is increased more and more, then at one point the UJT will be on. UJT on means this will current will flow and the bulb will glow. Yes, after capacitor gets discharged, the capacitor gets discharged, current or UJT is on, current flow, bulb glow for some time, as long as capacitor voltage is greater to trigger the UJT. We know the capacitor voltage will drop, yes, and then again it will get charged, then again it will be charged, again from here the capacitor will be charged, and after charging some time t tau, which is RC, then again this voltage will be greater than this, so we will get here the output as like this. Yes, this repeats, process repeats depending upon capacitor charging and discharging. Thank you.